This is again a very important example of Riemann integration. This example signifies that a function can be bounded but it is not Riemann integrable. So such kind of function is given to us, that is fx equal to 1 if x is rational and is equal to 0 if x is irrational in closed interval 0, 1. So we need to show that fx is bounded but it is not Riemann integrable, right? It is very clear that in this interval there are infinitely many irrationals and rationals. For that we have only two values of the function fx. For irrationals we are having 0 and for rationals we are having the value to be 1. Right? So obviously this function is in itself is a bounded function. So let's write this. And then we need to show that it is not Riemann integrable, right? Okay, let's move on to the solution. About the boundedness, since fx is either 0 or 1 in this closed interval 0, 1. So therefore, fx is bounded in 0, 1. To show that this function is not Riemann integrable, for that, let's take a partition P having the elements x0, x1, x2, x3 up to xn. Suppose this be a partition of closed interval 0, 1. Then what is the lower Riemann sum? This is equal to the summation I going from 1 to n, small mi, delta I. What is delta I? It is xi minus 1, the length of this subinterval, right? So this can be written as summation I going from 1 to n, small mi, xi minus 1. Now as in this closed interval xi minus 1 xi, there are infinitely many rationals and irrational numbers. So what will be the minimum value of the function in this interval? That is 0 for irrational numbers. And what will be the maximum value? It is 1, right? So here mi is the minimum value of fx in closed interval xi minus 1 xi. So from this can we say that the minimum value of fx in this interval, closed interval 0, 1 is 0 and the maximum value is equal to 1. Same values for this interval also and for this interval also, because there is an existence of only two values of x, either 0 or 1 for infinitely many irrational numbers and rational numbers respectively, right? So let's write this. So as there are infinitely many rational numbers and irrational numbers lying between closed interval xi minus 1 xi, therefore their minimum value is 0 and maximum value is 1. Therefore, small mi, that is the minimum value of fx, is 0 in closed interval 0, 1, and capital Mi, that is the maximum value of fx, is 1 in this closed interval 0, 1 also. So therefore, LPF is equal to summation I going from 1 to n, small mi, xi minus 1. So this is equal to summation I going from 1 to n. This is 0, xi minus 1. There is no need to calculate this summation. Already 0 is multiplied with this. So this is equal to 0. So LPF is 0, the lower Riemann sum. Now finding the upper Riemann sum, that is equal to summation I going from 1 to n, capital Mi, xi minus 1. So this is equal to summation I going from 1 to n, this capital Mi is 1 and this is xi minus 1. Let's put I equal to 1 over here, we get x1 minus x0. Then putting I equal to 2 we get x2 minus x1. Then x3 minus x2 up to so on xn minus 1. So here x1 is cancelled out with this x1, x2 is cancelled out with this x2 because of the opposite signs. So likewise xn minus 1 also be cancelled out with another xn minus 1. So all the terms would be cancelled out and the remaining terms will be xn minus x naught. And in the closed interval 0, 1, we always take this to be x naught and this to be xn. So that is equal to 1 minus 0, which is equal to 1. So UPF is 1, the upper Riemann sum is 1. Now to check the lower Riemann integrable and the upper Riemann integral. If both are equal, then function is Riemann integrable. But if both are unequal, then we say that function is not Riemann integrable, right? So in this case, the upper Riemann integral and lower Riemann integral should not be equal. Calculating the lower Riemann integral first, that is equal to least upper bound of LPF. Or you can also say that supremum of LPF, where P is the partition in this closed interval 0, 1. So this is equal to, because LPF is 0, so LUB of LPF is 0. Calculating the upper Riemann integral, so this is equal to the greatest lower bound of UPF or the infimum of UPF, where P is the partition belonging to the closed interval 0, 1. We have calculated the UPF to be equal to 1, so the greatest lower bound of 1 is 1. So these two Riemann integrals are not equal. So fx is not Riemann integrable. So the lower Riemann integral is not equal to the upper Riemann integral. So therefore fx is not Riemann integrable. In closed interval 0, 1, even fx is bounded on closed interval 0, 1. Right? So this is an example of the function which is bounded but not Riemann integrable, right? Okay, thank you. Stay blessed.